Picture this. You type a prompt, hit generate, and before you can even blink, a full resolution image pops onto your screen. Not after a progress bar, not after 100 little denoising steps. Just tap, and it is there. That is the experience Apple is chasing with a brand new model called STARFlow, and it is not locked behind a paywall. It is sitting on GitHub, free and open for anyone to download. Here is the wild part. Apple, the company famous for sealed boxes and locked ecosystems, just open-sourced a state-of-the-art image and video generator that can run up to 15 times faster than many diffusion models from OpenAI, Google, or Midjourney. No subscription, no rate limits, just code, model weights, and a research paper. In a minute, we are going to see why this single move could hit the entire AI subscription economy right where it hurts. Let us start with what STARFlow actually is. Apple released two models, STARFlow for images at around 3 billion parameters and STARFlow V for video at roughly 7 billion. They run in the latent space of autoencoders, so they never have to juggle raw megapixel grids directly. That keeps memory and compute surprisingly manageable for something this powerful. But here is the pattern break. Unlike Stable Diffusion or DALL-E, STARFlow is not a diffusion model at all. Most of the image generators you have tried work like sculptors in reverse. They start with pure noise, then take 20, 50, even 100 tiny denoising steps to gradually reveal a picture. Every step costs time, GPU cycles, and money. STARFlow does something closer to a magic trick. It learns a perfectly reversible mapping between simple noise and the final image, so sampling is basically one forward pass through a big transformer, plus decoding. That is where the 15 times faster headline comes from. On an A100 class GPU, a diffusion pipeline might need 1 to 1.5 seconds to walk through 50 to 100 steps for a high-quality image. STARFlow can hit similar quality in under 1/10 of a second because it skips the whole Markov chain dance. Scale that up to millions of images or frames and the math is brutal. A service that needed 100 GPUs for diffusion might get away with a fraction of that running flow-based models. But this is not just about speed for bragging rights. Lower step counts mean lower latency for real-time tools, lower cloud bills, and higher throughput per server. For you, it feels like snapping a photo on an iPhone instead of waiting in a digital darkroom. For any company hosting generative video, STARFlow V is even more dramatic. Traditional diffusion video models chew through dozens of steps per frame across 16 to 24 frames. STARFlow V slashes those passes while still keeping clips coherent. Under the hood, Apple is betting on something called normalizing flows. Think of STARFlow as a bilingual dictionary between Gaussian noise and finished images, where every mapping is precise and reversible. The engine is TARFlow, a transformer autoregressive flow. Instead of predicting the next word in a sentence, it predicts how to transform continuous latent variables that encode the image. Running in a compressed latent grid lets the transformer focus on structure, composition, and global detail without drowning in pixels. Flows are not new, but they used to lag behind diffusion on pure image quality. Early models like Glow produced crisp yet simplistic samples and struggled at higher resolutions. Apple attacks those weaknesses directly. TARFlow relaxes some of the strict architectural constraints, operates in latent space, and adds guidance similar to classifier-free techniques to sharpen outputs without paying the diffusion step tax. Their benchmarks show quality approaching or matching top diffusion systems at 512 by 512 and above, while still sampling up to 15 times faster. Now here is where things get really disruptive. Apple did not just publish a paper and a teaser demo. They open-sourced the code, the training configs, and the actual weights under a permissive license. A solo developer can clone the repository, rent a single powerful GPU in the cloud, and stand up a fast image generator that rivals mid-tier diffusion models without paying per prompt fees to anyone. This is a direct shot at the business model behind OpenAI, Google, and Midjourney. Think about what that means. If a free, locally hosted model is good enough for marketing images, storyboards, or 480p video, why would teams keep paying several cents per image or per short clip to closed API providers? Suddenly, closed platforms have to justify their prices with more than raw model quality. They need exclusive data, compliance guarantees, or deep integrations. And if a Fortune 500 company can run Apple weights inside its own Kubernetes cluster, the leverage shifts fast. There is also a values battle hiding underneath. Control over foundational models decides who sets the rules for watermarking, copyright filters, and surveillance hooks. Until now, that power sat mostly with a few United States cloud giants and closed labs. By open sourcing a flagship class generator, Apple just armed the open source side with serious firepower. If STARFlow class systems spread across Mac, Linux, and even Android, the future of generative AI starts to look more like the early web: chaotic, decentralized, and very hard to lock back down. Of course, too good to be true usually means there is a catch. And with STARFlow, there are several. First, this release is a research preview, not a polished mid-journey killer. You get raw power, not a glossy web app. Apple gives you PyTorch code and notebooks, but you are responsible for your own user interface, job queuing, upscaling, and integration. If you want a friendly Discord bot experience, you have to build it. Hardware is the next big asterisk. A 3 billion parameter image model and a 7 billion parameter video model are not toys. To get low latency, high-resolution output, you are looking at RTX 4090 class cards or data center GPUs with 24 to 80 gigabytes of memory. Try to squeeze STARFlow onto an 8 or 12 gigabyte consumer card and you will face trade-offs: lower resolutions, slower batches, or offloading to multiple GPUs in the cloud. That 15 times speedup assumes you can keep the whole model resident and push it hard. Then there is safety and reliability. Unlike closed platforms that bake in content filters and moderation, STARFlow arrives almost bare. There are minimal safety guardrails, no built-in policy enforcement, and no abuse monitoring. If you deploy it in a product, you are the one who must add NSFW detection, copyright filters, watermarking, and logging. That freedom is powerful, but it also shifts responsibility directly onto developers and companies. Quality itself is strong, but not perfect. Normalizing flows have historically struggled with ultra-fine textures, hair, and tiny text that mature diffusion models handle well after years of tuning. Early STARFlow samples look sharp overall, but sometimes show mushy micro detail or subtle artifacts in very busy scenes. Video has limits too. STARFlow V is currently aimed at roughly 480p coherent clips, not native 4K cinema. You can upscale, but that eats into some of the speed and cost advantages. So what is Apple really playing for here? Look at the bigger picture. Apple wants on-device generative AI that feels instant, private, and native to every iPhone, iPad, and Mac. Diffusion, with its dozens of denoising steps, is a tough fit for a battery-powered device. A single-step, flow-based generator is a much better match for A-series and M-series chips with tight power budgets. Reality check, though. You are not going to run today's multi-billion parameter STARFlow checkpoints natively on an iPhone 15 Pro without brutal compromises. Even with quantization, pruning, and core ML optimizations, these models want more memory bandwidth and VRAM-like capacity than current phones expose. Instead, STARFlow looks like a design target for future Apple silicon. Expect upcoming chips to bulk up neural engine throughput and on-chip memory specifically to handle fast, flow-based generation for photos, short video, and maybe even 3D assets. Once that hardware lands, the software story almost writes itself. Imagine on-device wallpaper and lock screen art that is generated uniquely for you without ever touching a cloud server. Logic Pro and Final Cut Pro could spin up custom B-roll, textures, and transitions in seconds. Xcode might generate UI mockups and app assets on the fly. And because the model lives on your device, latency drops and privacy improves at the same time. For you, whether you are a developer, a creator, or just AI curious, STARFlow sends a clear signal. Generative models are moving from rented services to tools you can actually own and run. The cost of experimentation is dropping. The speed is jumping. And the rules about who controls what you can generate are suddenly up for negotiation again. This changes who gets hired, which startups survive, and how creative work gets done. So here's the question I want you to wrestle with. When a company like Apple open sources a model this strong, do we end up with a freer, more creative internet, or just faster, cheaper ways to flood the world with synthetic content? The answer is not decided yet. It depends on how people like you choose to use, fine-tune, and deploy tools like STARFlow. In future videos, we will dig into hands-on workflows and what this could mean for jobs in design, film, and software. If you want to stay ahead of this next wave of generative AI, now is the time to pay attention. Download the paper, skim the code, or at least understand the shift from diffusion to flow, because the tools you rely on in 2026 and beyond may be built on exactly this kind of architecture. Hit subscribe if you want deep dives into STARFlow, open source models, and the real-world impact on creators and developers. And tell me in the comments, what would you build if you had a 15 times faster free image and video generator running under your control?